Good morning students, we have already started second chapter of algebra, that is quadratic equations. In this chapter we see methods of solving quadratic equations. Now in this video we see second method of solving quadratic equation. This method is completing square method. Let us see how to solve a quadratic equation by completing square method. Here this is quadratic equation x square plus 10x plus 2 equals to 0. This is quadratic equation, we know that. Now let us try to solve it by splitting the middle term, that is by factorization method. Product of constant term with coefficient of quadratic term, product is 2. Coefficient of middle term is 10. Now we have to find two numbers such that product of them is 2 and addition of these two numbers is 10. We cannot find such numbers. It is not possible to find such numbers. In such cases, it is easier to solve the quadratic equation by another method. It is called completing square method. Let us learn this method by using that example. First step is modify that equation into standard form of quadratic equations. Ax square plus bx plus c equals to 0. This is standard form of quadratic equations. Now you see that this is equation already in the standard form. Now here that polynomial is not square polynomial because that polynomial is not square of any of the linear polynomial because of third term. Here third term is not suitable, so we transfer that third term to right hand side. X square plus 10x equals to minus 2. Now we have to add new third term so as to that polynomial is square polynomial. X square plus 10x plus k equals to minus 2 plus k. We should add third term on both sides because of equalized that equation. Here k is new third term. Now we have to find value of k by comparing that polynomial with square polynomial. There are identities of square polynomials. We know that it x plus a bracket square, expansion of that square polynomial is x square plus 2ax plus a square. This is an identity. We already known about it. Now second identity is x minus a bracket square equals to x square minus 2ax plus a square. Out of these two identities we have to use one of them. Here look at the sign of middle term, plus sign, so you must use first identity here. Now that compare that polynomial with expansion of square polynomial. X square plus 10x plus k equals to x square plus 2ax plus a square. Here middle term is 2ax and in that polynomial middle term is 10x. So 2ax equals to 10x. So here we have to find value of a. 10x upon 2x. Multiply 2x by transferring it on right hand side. It get divided to 10x. Now by reducing it, x cancel, 2 1s are 2, 2 5s are 10, value of a is 5. Now value of k is a square, so k equals to a square equals to 5 square equals to 25. Now value of k is 25. Substitute this value. Substitute that value in equation first. We get x square plus 10x plus value of k is 25 equals to minus 2 plus 25. Now this is square polynomial. Now what is that polynomial which is square of this expansion? That polynomial is x plus 5 bracket square. How can we find? Let us see a trick. That square polynomial x square we take root of that square polynomial as x, so only sign of middle term plus, and root of third polynomial is 5 bracket square. आता ह्याचा स्क्वेअर हा हेच पॉलिनॉमियल आहे का नाही आपण चेक करू शकतो. x plus 5 bracket square we can write it as x plus 5 and into x plus 5. Multiplying these brackets, x into x is x square, x into 5 is 5x, 5 into x is 5x, and 5 into 5 is 25. Look at here, x square plus 10x plus 25. This is the polynomial. So we can write that polynomial as x plus 5 bracket square. Here 25 minus 2 is 23. By taking square root, x plus 5, root of x plus 5 bracket square is x plus 5 equals to root of 23 is plus or minus root 23. We know that negative 5 square is also 25 and 5 square is also 25. So root of 25 is equals to plus or minus 5. So we can write is root of 25 root of 23 as plus or minus root 23. Now we should find value of x, so we can write x equals to plus or minus root 23 minus 5. So plus, we take plus root 23 minus 5 as value of x, or x equals to minus root 23 minus 5. These are the roots of that quadratic equation. Let us solve another equation by completing square method. This is a quadratic equation, 5x square minus 4x minus 3 equals to 0. Look at the quadratic term, it is not perfect square. म्हणजे perfect square नाहीये, कारण 5 चं रूट इंटिजर होऊ शकत नाही, म्हणून आपल्याला ह्याला परफेक्ट स्क्वेअर बनवावं लागेल. त्यासाठी each and every term ला 5 ने डिवाइड करावं लागेल. डिवाइडिंग by 5, 5x square upon 5 minus 4x upon 5 minus 3 upon 5 equals to 0 upon 5. 5 getting cancelled, x square minus 4x upon 5 minus 3 upon 5 equals to 0. Now that polynomial is not perfect square because of third term, so we transfer that third term on right hand side. Then x square minus 4x upon 5 equals to 3 upon 5. Now we should add new third term so as to get that polynomial, a square polynomial. We add new third term, that is k, on both sides so as to equalize that equation. Now this is the polynomial. We have to make that polynomial a square polynomial by comparing that polynomial with square polynomial. We know that x minus a bracket square equals to, this is square polynomial, and expansion of that square polynomial is x square minus 2ax plus a square. We should compare that polynomial with this polynomial, x square minus 4x upon 5 plus k equals to x square minus 2ax plus a square. By comparing middle term, we can write minus 2ax equals to minus 4x upon 5. By eliminating negative sign, we can write 2ax equals to 4x upon 5. Multiplying 2x, here we have to find value of a. Multiply 2x, by transferring it on right hand side, it will be divided to 4x. By reducing, you will get value of a 2 upon 5. Now value of k is a square, so value of k equals to a square equals to value of a is 2 upon 5, so 2 upon 5 square is 4 upon 25. Now we have to substitute that value of k in equation first. By substituting value of k in equation first, we can write it as x square plus minus 4x upon 5 plus value of k is 4 upon 25 equals to 3 upon 5 plus value of k is 4 upon 25. Now this is the square polynomial because we can find root of first term and also root of third term. आता हे स्क्वेअर पॉलिनॉमियल आहे. आता कोणत्या लिनियर इक्वेशनचा स्क्वेअर पॉलिनॉमियल आहे ते आपण पाहू शकतो, मिळवू शकतो. कशी बघा, फर्स्ट टर्मचं रूट x, मिडल टर्मचं ओनली साइन and last term's root 2 upon 5 bracket square equals to, here we should equalize denominator by multiplying 5 to numerator and denominator. 5 3 is 15 upon 25 plus 4 upon 25. X minus 2 upon 5 bracket square equals to, here denominators are equal, so we can write it as 15 plus 4 x minus 2 upon 5 bracket square equals to 19 upon 25. By taking square root, root of x minus 2 upon 5 square is x minus 2 upon 5, and root of 19 upon 25 is plus or minus root 19 upon 5. Now x equals to plus or minus root 19 upon 5 plus 2 upon 5. Value of x is plus 19 root 19 plus 2 upon 5, or value of x is negative root 19 plus 2 upon 5. These are the roots of that quadratic equation. Let us see another example. 5x square equals to 4x plus 7. First, you have to modify that equation into standard form. 5x square minus 4x minus 7 equals to 0. We know that standard form is ax square plus bx plus c equals to 0. Now we modified that equation into standard form. Let us see the quadratic term. Here quadratic term is not perfect square, so by dividing by 5 on both sides, we can write it as x square minus 4x upon 5 minus 7 upon 5 equals to 0. Now look at here, that polynomial is not perfect square because of that third term, so we transferred that third term on right hand side. X square minus 4x upon 5 equals to 7 upon 5. Now add the new third term on both sides. New third term is k Now we have to find value of k by comparing that polynomial with perfect square polynomial. Perfect square polynomial is x minus a bracket square. This is perfect square polynomial. Expansion of that polynomial is a square x square minus 2ax plus a square. By comparing it with x square minus 4x upon 5 plus k equals to x square minus 2ax plus a square. Comparing the middle term, we can write it as minus 2ax equals to minus 4x upon 5. By eliminating negative sign, 2ax equals to 4x upon 5. Value of a is 4x upon 5 into 2x. By reducing it, value of a is 2 upon 5. Now, value of k is a square. Value of k is a square. By comparing it, a square is 2 upon 5 bracket square is 4 upon 25. Now, put that value in equation first. Then equation first is x square minus 4x upon 5 plus 4 upon 25 equals to 7 upon 5 plus 4 upon 25. For equalizing denominator, we should multiply 5 to numerator and denominator of first fraction. Now x square minus 4x upon 5 plus 4 upon 25 equals to, by multiplying it, 35 upon 25 plus 4 upon 25. Now this is perfect square polynomial. By taking root of quadratic term x, sign of middle term only, and root of last term 2 upon 5 bracket square. Square of that linear polynomial is x square minus 4x upon 5 plus 4 upon 25. We can check it by solving it. Equals to, here denominators are equal. We can add numerator x minus 2 upon 5 bracket square equals to 39 upon 25. By taking square root of that polynomial is x minus 2 upon 5 equals to root of that term is plus or minus root 39 upon 5. Now x equals to plus or minus root 39 upon 5 plus 2 upon 5. Value of x is root 39 plus 2 upon 5 plus or minus. Now there are two values of x. Value of x is, by taking plus root 39 plus 2 upon 5, and second value is root 39 plus 2 upon 5. These are the roots of that quadratic equation.